Okay, so this video is going to help you with the prep quiz for section 2.5 optimization problems. You'll find that section 2.5, there's nothing really all that new to talk about. We're just actually going to be starting to talk about the reasons, the applications for why we've been finding the maximum and minimum for all these functions in the past few sections. These few problems on the prep quiz are just hopefully just to kind of get you familiar or remind you about maximum and minimum, and we'll talk more about the actual applications in class on Wednesday. Here are two examples of problems you'll see, just like the problems on the prep quiz. Hopefully these should help you when you're working through those two problems. It's nothing, we're not doing anything new or different in these two problems. For this one, it says find the minimum value of f of t equals 3t cubed minus 36t squared plus 80 when t is greater than or equal to 0. Okay, so to find the minimum value, remember you need to find the critical points. So to find the critical points, we need to find f prime of t, which is going to be 9t squared minus 72t. And then, of course, let's go ahead and find f double prime of t. So that's going to be 18t minus 72. So remember, maximum and minimum values occur when the derivative is 0. So we're going to set the derivative equal to 0. And solve for t. So do you see if we factor a 9t out here, we're left over with t minus 8. We set each term equal to 0. So we get t equals 0 and t equals 8. So these are two t values or x values. Now to find the corresponding y value, we plug these values back into the original function. So we're going to find f of 0 is going to be, what, 80? So our coordinate points are going to be 0, 80. Then we'll find f of 8. F of 8 is going to be 3 times 8 cubed minus 36 times 8 squared plus 80. Which comes to be negative 688. So we get, so we'll have 8 and negative 688. So we have two critical points. We have 0, 80, and we also have 8, negative 688. So to find which one is a maximum, or which one is a minimum in this case, we need to determine the concavity. So we use the second derivative, and we say 18 times 0 minus 72 is going to be negative 72. So that's going to be concave down. Looks like this. So that's going to be a maximum. So the other one obviously has to be the minimum, hopefully. So let's say 18 times 8 minus 72 is going to be 72, which is concave up, which means it is a minimum. So the point, we'll do this in pink, the point 8, negative 688 houses the minimum. Now, here's the question. The question is saying find the minimum value. So the minimum value is, the y value is negative 688. And it's located at t equals 8. That's very important that you understand the difference between The value is all, the minimum or the maximum value is always the y value, and it's always located at the x value. Okay, and then the next problem is like the third problem that you'll see in the prep quiz. If you're asked to find the maximum of q equals xy if x plus y is equal to 62, this is another problem that's very similar to everything we've been doing before. The only catch here is we've got x and y for variables. So all you do is we use this second equation, x plus y equals 62, to isolate y. So y equals 62 minus x. Now we can plug this in for y and q. So we say q, instead of being xy, q is going to be x times 62 minus x. So that is also 62x minus x squared. So if we want to find a maximum, again, we've got to find the derivative. So let's find q prime, which would be 62 minus 2x. Go ahead and find q double prime, which is going to be negative 2. And now, to find the maximum, we're going to take q prime and set it equal to 0. Solve for x, so we'll move the 2x over, so we have 2x equals 62. Divide both sides by 2. We'll get x equals 31. So we only have one critical point here, so that obviously is going to have to be a maximum. We still are going to want to test it, but let's go ahead and find the y value of this critical point. So we're going to say q of 31 is going to be 31 times 62 minus 31. So q of 31 is going to be 961. So our point is going to be 31, 961. So the maximum value is, max value is 961, located at x equals 31. And last thing, you may want to just double check, make sure that this is a maximum. So we would say, do you see that when, if you look at q double prime, there is no variable. So no matter what x is, it's always going to be concave down, which looks like this, which means it's always going to be, any critical point is going to have to be a maximum. So that means that this makes sense. So I hope these two problems help.